Now we are going to look at related rates. The related rates is the use of the implicit differentiation to find the rate of change with respect to time. The other way we say the problem has two or more variables and both of them depend on the variable time t. And your goal is to find the derivative of whatever the quantity with respect to time t instead of with respect to x or with respect to y. So for this example, x and y are functions of a third variable t. Use implicit differentiation to find an expression for dy by dt. The key term, you see the independent variable, which is the variable of the time t, and t doesn't appear in the expression that we have. This is the implicit because x and y are over the place, implicit, and at the same time, x as the function of t, y as the function of t. And your goal is to find dy by dt. Based on implicit differentiation, the first step, we're gonna find the derivative with respect to time. And that means you have 1, 2, 3, 4, 4 pieces. We're gonna find d by dt of the x plus d by dt of the quantity 2xy minus d by dt of the quantity y squared equals d by dt of the quantity 6, one by one, term by term. As you don't see t within the expression at all, we are going to treat them like you are using the general power rule and other rules as appropriated. Okay, that means you're going to multiply by the derivative of the quantity that you see. So the first one, the general power rule, we as x to the first power, so going to be 1 times x to the power 0 multiplied by x prime. And the next term, we have the quantity 2. I'm going to put one more step here, since we're going to find the derivative with respect to time of the product. And then minus, and this one again, we're going to use the general power rule. So if I put it here, general power rule, this one general power rule, this one has a product. We'll come back to put more detail. And y to the second going to be 2 times y to the first multiplied by y prime equals 0, which is the derivative of the constant. Now clean up a little bit. We know x to the power 0 equals 1. So the first term is just the x prime. And then plus the 2 times the product. Gonna be the derivative, the first one multiplied by the derivative of the second, and the other way around. Use the product. At this step, we apply the product rule. As you consider this as the f and the g, so this is the f times g prime, and this is the f prime times g. Minus 2 times y prime equals 0. And to keep the notation consistency, so I'm gonna use the dy by dt as the y prime and the dx by dt as the x prime, or maybe the other way around, sorry, the other way around. So the x prime is dx dt, the y prime is dy by dt. So I will keep it as the full notation. So this is dx dt plus 2x times dy by dt plus 2 times y times dx dt minus 2 times y times dy by dt equals 0. And we are going to find the dy by dt. Okay, so far the step of the first part of the implicit differentiation is done. So the next step in the problem asks you to find the dy by dt. Look for the dy by dt right here, dy by dt right there. So 2 places. We're gonna have to rearrange the term a little bit and move the term that doesn't have dy by dt to the other side. So the left-hand side will become 2x dy by dt minus 2y dy by dt. This is a product, okay? Equals negative dx dt plus, not plus, gonna be minus sign. Minus sign. 2y dx dt. Okay, and as you see that you have the common factor here and also the common factor for the other group. So we're going to regroup them to be 2x minus 2y multiplied by dy by dt equals negative 1 minus 2y quantity. Both of them share the same common factor dx dt. Since we are going to solve for dy by dt, I'm going to divide both sides by 2x minus 2y, 2x minus 2y. And our answer dy by dt equals the quantity negative 1 minus 2y divided by the quantity 2x minus 2y multiplied by dx dt. dx dt consider one quantity. Okay, so this is the answer for this problem.